So let's begin with a very straightforward differential equations dy dx equal to x. We're going to try to solve this. This sort of differential equation has a name because it can be separated. We'll talk about that later, and we call them separable differential equations. The idea is that say there's a differential equations which are something like this dy dx, and in the process you can manipulate differential equations, and in the end you get something which equal to a function in terms of x divided by a function in terms of y. Now it's not necessary that you must get this, but that's a general idea. You're able to write the differential equation in this form. When that happens, we call these differential equations separable, because I'll show you why. First thing we can do is, of course, we can write gy as follow, and then we have dy dx, and then we'll left fx here. If we want to then reverse the process of differentiations, understand that this process is a differentiation, so we want to reverse the process. So what we do then is that we integrate it, okay, both sides. With respect to x, that is a very valid operator or operations. Both sides we're doing the same thing. So what happens now, especially pay extra attention to this part here. Here we actually differentiated y, and then here we integrate it again, sort of. So dy dx can be replaced just by dy alone, and this will still be here, this will still be here, and this too. And give you a different feel of this. So the gy remains, of course, equal sign of course remains, and the fx, and now voila, you have two integrals, and you just separated the differential equations, and you will go on from here, resolve both sides, and then you get a solution to the original differential equation. So right here, we quickly just show you how it is done. Again, we take this. The aim is to actually collect dx with x, and then any y term, y expression with dy. Since there's no y term there, just let it be. This is dx, and then dx here. And you're going to integrate this with respect to x. Similarly, the left hand side, because we already justified that this is actually dy, the left side, and the right side would still be the same. Eventually, this will be the general solutions to these differential equations, and this process is the separation process, and you perform the integration also. Let's look at another example, slightly harder, and see how it goes. So here we are. We have dy dt equal to square root of y over 3, but we do know that square root of y is actually y to the power of half, and this is just really 1/3. This is a different way of writing it. So we can separate this, because we can think of it this way. This is y power negative half, and we multiply both sides by that. This still you have dy dt, and 1/3 still here. What we're going to do is we're going to integrate both sides with respect to t, because the independent variable this time is t. So dt this side, and dt for the left side also. Would end up getting something like this. Understand that dy dt is really dy, and so now we integrate both sides with respect to t and y respectively, and just perform the integrations and simplifications of multiplied by 3 and so on. So you get this solution. This is a general solution, but fortunately, given the initial conditions, so we will be able to find the value of c, or 3z in this case. So all we need to do is just substitute this the y as given here. you should be able to see something like this is 9 power half, t is 44 plus 3c. You should be able to show that 3c is 3 negative 26. I don't have to find the c value because I'm going to substitute back into this run right here. So what we get in the end is 6y to the power of half equivalent to t minus 26, and that will be the solution or particular solutions of this differential equation given the initial conditions. And the process that used right here is separations or separable techniques. So this differential equation is a separable differential equation. This is one example of it. So one more example here. This example I will probably use this to describe a simpler way of looking at performing the separations. Okay. So here, firstly, look carefully. This is e power of x. That means that the independent variable is x and the dependent variable is y. And so we know that y prime is actually dy dx. Let me give it some space. Now, you have to understand that this way of looking at the separation is not really technically correct, but we can think of it that way. Okay, so we can see that alright, here's the dx and here's our x term. How do we group this and this together? Well, you can think of it this way. You can think of it being performed this. You multiplying both sides by dx, so this would disappear, right? Vanish. Okay, that's the idea, right? It's not entirely the right technically. So this is like multiplying both sides by dx. So this will be cancelled out by dx, and here you have dx. And then the next aim is to actually collect a group the dy with y, because that's always our aim, to group the x term or x expression with dx and the y with dy. So of course the best way would be the multiplying both sides by 1 over y. When we do that, this would be cancelled out, and you will have 1 over y here. Okay, you get the idea. And so I'm going to redo this, but now with the way we look at the separations and do it, the step will be way faster and don't have to perform certain steps that required, but we don't have to do that. Okay, so the next step, once we given this one, would be to write in such a way that they'll be separated like this. So this is as if dy, dx is written here, and in dy group with the y. It's just like doing some algebraic manipulations. Not entirely the correct idea, but you can see that way. Then integrate both sides respect to the respective variables, and in the end you will get this, and we're replacing the constant. And by now you should be able to have the ability to perform the integrations. So I skipped that part, but the idea is to look at how we actually perform the separations. And if you want to master this, try and a few more exercise, practice more, you will understand how to do this really quickly and also effectively.